Okay, so today hopefully I'm gonna be able to study the Jinja2 library. I think I changed some stuff from the way that it was yesterday. And pretty much when I was doing this with the key to differentiate them, it was taking a very long time to finish. I wasn't sure if there was something wrong with the script or it's just taking uh just normal to take a long time. Because other scripts were uh, I wasn't sure, but I felt like I did scripts with a lot of nodes before, like 800,000 or more. And this was supposed to have around 800,000. So I wasn't sure what was going on. So I decided to put a print statement here to see it unfolding as it went through. And it was taking a long time. Then I decided to make some modifications to see if I filtered the script, it would work faster. Then I tried to filter through this, but then I realized that there was something wrong with that. And then I decided to just drop the key to make the values not unique. And then it all of a sudden went extremely faster. And it worked. So I don't really understand why this happens. Maybe it has something to do with the way that Network X works. But I don't think necessarily the number of nodes is the problem here. Because the other ones, even though they were unique and sequential like this one, it wasn't taking that long. So I'm not sure what was going on. But then I decided to leave it like this. And once when I did without this /n here, some description of some of the nodes were too long. So I decided to put this, and apparently it works. I believe it works. When you do it like this, it just gets a new line on the description of the nodes. And now I'm filtering through these libraries, and I haven't looked at the script yet. But I think I'm gonna change the function name to the file name instead. Because function name seems a little bit more confusing. And this is the resulting thing. So I think I'm gonna go through this right now and see what happens, and then I'm probably gonna change to file name instead after going through this. So I think I'm gonna go directly through the Jinja2 ones. Oh yeah, and I'm gonna put timer just to see how much time spent here. I think I'm gonna go running after this. And then I come back later. Should keep going. Yeah, so here is the description of the function name. And the bottom line is what's being called, the variable names. Self height with directed notebook is moving because the physics, self layout and options, self. So the annoying thing about doing this in stream is that I have to do it like this, but whatever. So my concern is that this is not really gonna work or be useful at all. So it's calling this self and layout. on the init object. So I can't be this one. That should be this one. Oh, I think here's when he's making the layout for the graph. Not the nodes or edges, just the graph itself, background, stuff like that. Then it goes through south. Yeah, but that doesn't help that much. I don't know what south is. Maybe it's just the layout, south layout. Self enabled filter. It's probably because of the show buttons stuff. No, here. So this is the configure. Yeah, maybe I should try to see if I can change. Oh, the other thing I just remembered is that when I was talking about this code salvars and code prevars, I already changed them to string as I was getting the information, and I forgot about that. So to make them, to convert them, I would need to convert from string of the hexadecimal representation into the name representation. So here's going to the south in physics. Yeah, I think what's happening is as it's going through the layout, it goes through the other options here. Goes to physics. I think it's hard to know what south is. What object add node. 5 is network. Self, NID, label, shape options, not label. So now it's adding the nodes. 5 is network. Self, NID, label, shape, options, node ID, node label, and so I think the options is passed as node label and node underscore label and self and ID shape label font color opts by visnode.py. So it's just getting the creating the object now. Self source true options edge exists from destination. Setting the edge and checking if the node exists. Edge exists. Get nodes at this address file. I was getting the nodes. I think yeah, because when it's gonna check if it exists or not, it gets the node here. Just referencing self. Self source that's directed options. Edge.py. Yeah, so I think this portion here is just the loop to add all the nodes and edges. I think it just goes over and over again. That's why they're all in a circle like this. Gotta just the list, self, a list, I, e source destination. So now it's running through this function. Maybe it's not a function, but I remember seeing this get adjusted list here somewhere. Yeah, here. So it is a function. This one I haven't seen before, and the other times I did this. Turns the user and adjacency list representation of the network. Turns dictionary mapping of node ID to list of node ID. It is connected to. And it's passing self, a list, I, e source, dest. So this is pretty much the local variables here, I guess, that I'm getting. I think that's what called var names returns, actually. Maybe I should just add a new line and put the code names for the global, like I put it here as a comment. And then after that, change the functional name to the file name. But maybe the functional name is better because I like seeing this, which thing is being activated. It is also giving me the file and the line. So maybe this functional name is actually better than just having the file name. Then I have to check to see because maybe the global variables are gonna be too big of a description. So I have to figure out a way to format that in a way that doesn't get too and that is not bad to read. So show buttons is referencing. So now is at the end of the script there. Self filter. And then goes through here again. So maybe the way that this connection is slightly different than what's actually happening because of the name of the nodes. Because I think what's actually happening is this is at the end of the loop. So it doesn't go directly through here. At least that's what makes more sense to me. It's just that it's connected like this because that's how the nodes work. But I think this one goes through here first, and then it goes on a loop until it finishes and gets through here. But maybe not. And this is just the option to see if the filter the bottom here is gonna be on or not. So self name show what line 467. So this writes a static HTML file and saves it locally before opening. The name of the HTML file should save. So this is the function that has the other functions that write the Jinja template. And then I comment this out so that it doesn't open the browser after it finishes, but usually it does. The standard it does. So now it goes through the utils, find var name, to assert if there is an HTML or not. So now it's going through this one. Line 407. Self name, notebook, use link template. Yeah, so the code var names is just giving me all the variable names for the local scope, I think. And title HTML content template nodes. I just heading height with options physics enabled. But it's interesting that I'm not seeing this directly, at least neither this get network data or this template. Yes, this is what I'm talking about. I guess annoying sometimes to read because there's too many lines. Maybe it's better if I do this in another script, the CSV manipulation one, and then I write again to CSV, where I can make some conditions to check the size of the lines, the size of the strings, and if they pass a certain amount, I insert a new line between them. So it's referencing. So this is the object new, a Jinja environment. So here is the point that goes from the 5is stuff to Jinja. And I guess it goes through here. Yeah. So that's the path. And now it's just gonna give me all these variables here. So this is not quite what I want, actually. I wonder if it's even possible to get what I'm trying to get from here. Because what I would like to get is not CLS, for example. It's just the name of the stuff from previous ones. But maybe through the combination of global and local variables, I can just deduce what the thing is referencing to, because this comes from obviously the previous steps. So source, block start, string, all these variables here. Line extensions, optimize, then define, finalize, outscape, enable sync. Now it goes through this get spontaneous environment. Yeah, but here is not showing all these variables. I guess it's because it already did on the previous. Now it's just passing them or something like that. Oh no, this is line 65. So it's a different thing. Yeah, so that one, it passes all the arguments to that one, I guess. And then it goes here. Return a new spontaneous environment. Spontaneous environment is used for templates created directly rather than through an existing environment. Environment class should create positional arguments passed to environment. Hmm. Yeah, I think I will need to get the solvers. Tuple of names of cell variables referenced by containing scopes. Tuple names of few variables referenced via a function's closure. I think maybe one of these shoes is gonna contain the information that I want. Which is annoying, to be honest, because then I have to spend a bunch more time trying to transform that into transform the hex memory thing into names. Because it doesn't help me to just see this CLSR key here. It's better than nothing, but because I can see what's being accessed in each node. So here I can see that it goes through here, but so I guess it hits this accept error, key error. And creates a new env. Now Jinja2 is this one. Line 420. So those two functions are connected somehow. What's going through here? No, this is the environment. I'm on the wrong file. Oh, it's because I didn't open manually. Oh, remember? So it's actually going through here instead. Line 420. So it's this line. Get an item from the cache. Moves the item up so that it has the highest priority then. Also here is returning RV. But what I don't understand is how it goes from this into the other. Oh, spontaneous environments is this LRU cache. For direct template usage, we have up to 10 living environments. So that's the connection, I guess. Because once it goes through this, it activates this stuff that I don't know. Yeah, but it's on the utils stuff. But it doesn't show here that it's being activated. Just kind of weird. So it's a func2 from Python. This one such function in func2's module, which helps in reducing the execution time of the function based on memorization technique. Next size. This parameter sets the size of the cache. The cache can store up to max size most recent function calls. Max size is set to none, the LRU feature will be disabled, and the cache can grow without any limitations. If type is set to true, function arguments of different types will be cached separately. For example, so I guess what's happening here is once it activates this, it creates a space on this cache, which is a way for the program to access the stuff easier because it is a different type of memory. Is a least recently used cache, which is basically used for memory organization. In this, the element comes as first in, first out format. We are given total possible page numbers that can be referred to. We are also given a cache or memory size, number of page frames the cache can hold at a time. The LRU caching scheme is to remove the least recently used frame when the cache is full and a new page is referenced which is not there in the cache. There are generally two terms used with LRU cache, let's see them. Page sheet, if the required page is found in the main memory, then it is a page sheet. Page fault, the required page is not found in the main memory, then page fault occurs. So maybe this is specifically used for creating HTML stuff because it makes the page faster. Let me go back to the thing. So it goes from here to here, get item in line 420. And it doesn't show this initialization stuff, which is interesting. It goes directly into the get item. So this is implying that it already exists on cache once the template is done. And I guess it's because of that function in the environment page. Base key error if it does not exist. So this goes through this loop here. Let me go back. Yeah, so now it gets to the interesting stuff. So the thing is, these are all connected, which is kind of confusing. That's why it would be good to have the unique flow, so I can see the direction of each one. Maybe I'll do that now. Yeah, I think that might be a good idea. So there are two things I want to do. But one I can do it later, which is to do this graph with the code names. So I can have access to the global variables as well. I'll put a new line here and put global names as well. That's one thing that I'm gonna do. The other thing that I'm gonna do is just add the keys here as well, again. Just so I get the unique value for each of them. And then I have to comment this out. But then I'm gonna have to make this let's put another name so that it doesn't overwrite this one while I'm looking at it. And then I'll show what I meant by if. Hopefully it's not as slow, but it's probably gonna be slow. And if it is slow, then I'm gonna make another file, copy this and change the name of the graph so I can do the other graphs while this one is being done. So let me run this. Oh no, here's graph. Yeah, so it's pretty much like I was doing before, but with the exception that now each one of them has a different key, which means each one of them is unique. And it's gonna show me the sequential line, hopefully, of what happens in the execution. And while this is being done, then I can check. Yeah, so this is the numbers of nodes here because it's printing the key in this function. And it seems very fast, but I think this has 800,000. But it's going a lot faster than it was going yesterday. So I'm not really sure what's going on. But maybe it will slow down once it gets to 100,000 or something like that. So this is on the utils. Get item. So raise a key, get an item from the cache. If something removed the key from the container when we read, ignore the value error that we would get otherwise. So self.mapping. The other thing that makes it difficult is that there's a bunch of different functions here. I guess this is just properties of the class that are meant should be private. Yeah, mapping is here is a dictionary. Then you have this double lock. It's not here, it's here. Posting it. Alias all queued methods for faster lookup. So, okay, I think I'm gonna go this route, then I'll come back and go the other one. So now goes through init on line 467 of the Lexer. Where is it? Lexer.py. Here. So again, we have this LRU cache. Cache for the Lexers exists in order to be able to have multiple environments with the same Lexer. What is a Lexer though? 900, 467. So it's going through this. Oh, so Lexer is this object here. Class that implements a Lexer for a given environment, automatically created by the environment class. Usually you don't have to do that. Note that the Lexer is not automatically bound to an environment. Multiple environments can share the same Lexer. So I think I can just search what is Lexer in Jinja2 template. Maybe I will use Google Translator because it might be that I'm not understanding what the word actually means. Lexer. So it says it's read. And I get more definitions. Lexer definition. In computer science, lexical analysis, lexing, or tokenization is the process of converting a sequence of characters into a sequence of tokens. A program that performs lexical analysis may be termed a lexer, tokenizer, or a scanner, although a scanner is also a term for the first stage of a lexer. So if I'm not mistaken, I guess this is for parsing stuff. So I think that's what's happening here is after it creates the nodes and the edges and the object, it activates the engineer template, which gets actually activates that get spontaneous environment. And the first step is obviously to tokenize everything from the PyVis objects into JavaScript format. So this is what this is doing here. Will be my guess. So line 467. So it's activating the init. Self environment C tag rules, root tag rules, block suffix re. flexing rules for tags. So I guess that's the class that formats this stuff. What is difficult for me to understand is how exactly, how does it know, like, can I put any object in the network and then it's just gonna do the same thing? It doesn't seem like that. It seems like there's steps missing here. Hey man, what's up? Assemble the root flexing rule because I is a greedy or I think this is a bitwise shift thing. We have to sort by length so that the lexer continues working as expected when I have parsing rules like this for block and this for variables. If someone wants ASP-like syntax, variables are just part of the rules if variable processing is required. Block suffix if trimming is enabled. So I guess I'll just walk around here. It's line 205. Environment E rows. So now I guess it's activating this probably. Yeah, it goes from there to here. Compiles all the rows from the environment into a list of rows. But what exactly are these rows? Like, how does it know from the PyVis stuff? Oh, I guess it's just getting from the environment. That's the thing. The environment's being passed through these other functions. Yeah, so it uses this to create a new environment through this here. Because once it runs this file, it's probably running this and creating the 10 caches already. Because here, this is at the top. Classes for mapping templates and their runtime and compile time options. Yeah, so I guess this is what is going on here. So, and as it imports all of this stuff, it has access to all of this stuff, the other classes already. And this method gets a class, which is the class of the network from this template stuff. Yeah, but my issue here is that this is an HTML or self.path. But there's nothing that implies that besides this stuff at the bottom here, it doesn't pass anything from the network directly into this template here. Oh, so I guess maybe it's creating the template first. This method gets the data structures supporting the nodes, edges, and options and updates the template to write the HTML holding the visualization. Here check the nature graph represents the overlay. It's present in overlay. because there's nothing of the network that goes directly into here. This content is just an HTML.read object, which is just a self.path read. And self.path is the path you put there. So I guess it's just creating a blank template first from Jinja. And then it goes through here and creates this spontaneous environment with the class and the arguments. Positional arguments passed through environment. But here I don't think it's getting any positional. Maybe the content. No, the content is what is being passed as a class. So the class is the path for the file, I guess. And there is no arguments, additional arguments. And then this goes through this to get the template from the cache that was already created, the beginning of the file. Something removed the key from the container when we read, configured the value error that we would get otherwise. And then it goes through this Lexer stuff, this file, which is creating the rules. Yeah, so I think this stuff just creates just initializes this LRU cache object and then goes back to the environment stuff. Because the next line, no, maybe not. Yeah, from the get item, it goes directly through that. So as is doing this, it goes through here, line 400. So maybe it's this acquire function. And so this is from Python. I think whenever a file has this .py with the I at the end extension, is just the Python built-ins module. So this acquire apparently is a function from Python. And I think another thing that I learned from Stack Overflow a while ago is that a lot of these functions in PyCharm that are built in from Python is gonna say pass as if there's nothing that in the method, but actually that's a PyCharm problem because the function actually exists, but PyCharm doesn't display it. So it's not that the functions. So here I think it might be a case of this happening where you just have the declaration of the function, but in reality this is actually running stuff. Just not possible to see it through PyCharm because it's probably written in C instead. At least that's what I suspect. I'm not really sure about that. So maybe is either this remove or release here. No, it has to go from that to the Lexer. And again, Python stuff. Maybe after it returns this RV mapping, it goes there. Maybe we should just search what's acquire and release. But I'm gonna keep going for a while here, just to see if I can. The main thing that I want, obviously, is figure out what point, at what point I can change the PyVis script so it generates different stuff in the template. That's the objective here. I think it obviously has to be in the PyVis script, but there might be something that I'm missing because from the times I've seen this before, I think it goes first from PyVis, then to Jinja, and then after Jinja, it goes to the networkx portion. So I think it might be actually the case that the connection that I have to change is on from Jinja2 to networkx, and not necessarily on the PyVis network. That's what I think I'm missing, because I'm changing. The last time where I tried to do this, I changed the function in a PyVis file, and it didn't have any effect here. So I think what's most likely going on is that PyVis actually is just like the cherry on top, where it activates the Jinja, but all the work is done through the actual networkx main class. And that's what's creating the template and this functionality here. So if I want to change the stuff that is happening here or with the nodes, I have to figure out where is the point that the networkx creates this stuff inside the template. So now, yeah, I think I've seen this, and now it goes to the goes to this function, which calls this one. So let me go a bit back to the other one, 167. So this is initializing this object b.scape def c, and I think it accesses this c, which returns re.compile x, which I'm not sure what it is. Oh, it's the argument here that is being passed, but I'm not, yeah, I'm not being able to access that, which is a problem. This is just returning me whatever is inside the function, not very useful. Yeah, but it's just returning up to here, so probably in this step is not activating the other parts. Yeah, maybe if I have the global variables, but I think the problem is gonna be that if I have the global variables, I'm just gonna have a bunch of stuff there. I'm not gonna be able necessarily to access these specifically. What is actually being passed from previous functions into this argument here. So it's probably gonna be the case, as usual, that I'm gonna have to do the hardest one, which is to figure out a way to get the cell vars or free vars in a readable format. So I guess this is, no, it's not. So it goes through here. Oh, so yeah, here. Assemble the root flexing rule. Because R is ungreedy, we have to sort by length so that the lexer continues working as expected. When we have parsing rules like this for block and this for variables. As flex syntax. Variables are just part of the rules if variable processing is required. Now deactivate this. Maybe it doesn't activate. Maybe the code var names is just giving me the names of the local. Yeah, arguments and local variables. So it's not really that useful. But here it says tuple of names of local variables as well. Name of which this code object was defined. Yeah, I'm gonna need, there's no way around it. I'm gonna need to see how to work with these ones. I think these are the ones that are gonna give me the information that I want. Because yeah, tuple of names of cell variables referenced by containing scopes. So this probably means that it's gonna give me the variables that are referenced via functions closure. So where was I? 467, I think. Oh, it's not on this. It's this. So turns this compile with this C, whatever that is. Then run some regex functions. Oh, and this object here, I realized before that I didn't know what it is. But now I know that this is just some old Python stuff where if you didn't put this before, then the classes were slightly different because of some reason that I don't remember really well. But on Python 3, I think it was, yeah, Python 3 and above, you don't need to put this anymore because all classes have that extra functionality. But before, you needed to specify this. So it doesn't mean anything necessarily. It's not that an object is being passed here, it's just that this works as a child class of this base class that existed back then to specify additional rules for the class. But now every class has that, so we don't need to specify it anymore. So now it goes through this one, which is this node. Compiles all the rules from the environment into a list of rules. So now it gets the environment object. I don't understand these rules really well. Gets the length, the token name, and this E object, which I don't know what it is. Oh, it's probably this re.escape, which is probably regex function to escape. Yeah, so re is getting to the re module. By a regular expression pattern, returning a pattern object. Escape special characters in a string. So this is creating the escape pattern for the regex. And then is using this here. Oh, so it's passing the environment.comment start string. I guess that's what's happening. So first it gets the length, then it gets the name of the token. Then it runs this function to tell that this is the beginning of the string by passing the environment and .comment string. And it's gonna do this for each rule that it has here. Token line statement begin. So let me see what's the other one. Lexer 243. So I guess it just goes through all the rules and then returns. This is this line here. .0x. So these just get all the rules from the previous step and put them into a list. List of rules through this list comprehension here at the bottom. Yeah, this is the code object that is being activated here. It seems like this is going a lot faster than it did yesterday, actually. So so I guess these are the basic rules that always apply, and these ones only go if the environment is specified on the previous, I think it was on the Lexer actually, the compile rules stuff. It was this page. So this is the compile rules. But it was on line 467, I think. Yeah, on the init, then you pass the rules. White space, float, integer, name, string, operator. So I guess this, what's this? This is doing is parsing Python into JavaScript, probably. But how does it have? Oh, I guess these conditions are probably for a different type of template where you already specified through the arguments when you're creating the environment. That's probably what's happening here. because on the network X, the network on PyVisit doesn't specify anything, but maybe if you specify things, then it changes here based on those arguments of the environment. Because if it's not none, it's gonna append this extra stuff. But in this case, it doesn't apply because it's not specified before. Maybe what I can also do sometime is just after I explore this a bunch of times, I'm just gonna make a lot of changes to the source code of these pages and see what happens. How does it break? I'm gonna break things and try to figure out how it's connected through that. That's an interesting idea as well. So is activating the list comprehension line for 100, 500. $518. Also, I guess it's because of the rules. Previous one. Global lexing rules. Oh, now it's just going back, I think. After it compiles the rules and returns that object, that list comprehension, then it activates this one, the main class. It's interesting that it's not showing anything here though. It's enabled, it should not be applied if there is any non-white space between the new line and block. So I guess, yeah, this is for old Python, I guess, where whenever you have this percentage s, you're just gonna replace with whatever is here. For n, r in root tag rules. So after it creates the rules objects and compiles them into a list comprehension, it activates this global self.rules. And then it runs this list comprehension here. Which is pretty much formatting the C object from before, which is re.compile, I think. No, re.escape. No. It's re.something that I forgot. And then it's just replacing. Oh, so this is the template. This is the format, I guess, for JavaScript. And whatever there's the percentage s is going to be replaced by the environment starting string block and string. So it's just parsing the string. It's a little bit hard to understand, but it's hard because I don't necessarily understood very well how it is actually creating the string initially, creating the codes that goes into here to be formatted like this. Maybe it doesn't exist yet, but then it doesn't make sense. Because it has to have something here to put here. So let me see where I'm at again. Someone this loop here. Yeah, maybe it's because of the way that the connection exists here. Is that stripping me up because I'm not necessarily going on chronological order. So it might be the case that I'm missing steps there because of that. So code object C at this address, Lexer Pi 471. So now it goes through this. The only variable is X. Oh, so wait a minute. Oh, so this is C. Oh, I think I get it now. So after it creates the rules, then it returns the list comprehension and creates this object here in the global rules. And this object returns is this C here with this argument. So X is this argument here with the rules. And then it's just gonna compile this with this regex stuff. Self-message CLS, Lexer 251. Template syntax error. So it's now is initializing this failure class. Class that raises a template syntax error called used by the Lexer to specify known errors. And then it goes back to this and loops through this file. So this node calls itself whenever there is this thing here. That's what it means. This circle there. Then it goes through the new 455 CLS member keywords. I'm gonna close the window because there's people making noise there. Just a sec. So line 400, so it's activating this one. Special tuple for making a point in the state that can have ls L strip applied. Special tuple for making a point in the state that can have L strip applied. Even though it looks like a no OP, creating instances fails without this. So if I'm not mistaken, this new is kind of like an init that gets called before the init method. So now it's activating this, which it returns super. Optional strip, CLS, new CLS member. So I think this has to be referring to the tuple class. Because it's the only, yeah, this is inherits from that. This is the Python built-in super. And this was what I was talking about. It's not that it doesn't exist here, it's just that the PyCharm doesn't display for whatever reason. Yeah, but then it creates this and it goes back to the 471, which is this C stuff there. So that's not that relevant, probably. And then it goes to this node here. Code object set item 442 in utils. So after it finishes this with the get item, then it sets the item. Self key value. Sets the value for an item, moves the item up so that it has the highest priority then. Try if key in self.mapping, self remove key, elif length, self.mapping equals self capacity, delete self mapping, self propla. I guess this release is for releasing the item from the cache, and acquiring is for acquiring the item in the cache, something like that. So first is it acquires whatever it builds on the get item stuff. Now here it has acquire and release. But I guess it's just functions to deal with LRU cache. At least that's what makes sense to me. So now it's gonna go through this loop and go here again. Yeah, now it gets confusing because. So I guess I can go through this path first. Yeah, I'm gonna go through here and then here. And then I do this lap here. I did this, and I can also go directly through here as well. It will let me look at all of them. So now let's go the other route. Code object init, package Jinja2 environment py line 288. So back to this. So now I think that is the stuff that I was missing before. And that's why I wasn't understanding really well about the rules. The core component of Jinja is the environment. It contains important shared variables like configuration, filters, tasks, globals, and others. Instances of this class may be modified if they are not shared and if no template was loaded so far. Modifications on environments after the first template was loaded will lead to surprising effects on undefined behavior. Here are the possible initialization of parameters. Block start string, the string making the beginning of a block defaults to this. Yeah, now it makes more sense. Block end string, the start string making the end of the block. Variable start string, the string marking the beginning of a print statement. Variable end string, the string marking the end of a print statement. Comment start string, the string marking the beginning of a comment. Line statement prefix, if given and a string, this will be used as prefix for line-based statements. Line comment prefix, string blocks, strip blocks. If this is such true, leading spaces and tabs are stripped from the start of a line to a block. Defaults to false. New line sequence. The sequence that starts a new line must be of RN or RN. The default is /n, which is a useful default for Linux and OS X systems as well as web applications. Keep trailing new line, Preserve the trailing new line when rendering templates. The default is false, which causes a single new line. If present, should be stripped from the end of the template. This is all the options of the escape, loader, cache size of the cache. Your default is 400, which means that if more than 400 templates are loaded, the loader will clean out the least recently used template. If the cache size is set to 0, templates are recompiled all the time. If the cache size is -1, the cache will not be cleaned. If this environment is sandboxed, modifying this variable won't make the environment sandboxed now. For a real sandbox environment, have a look at Jinja2 sandbox. This flag alone controls the code generated by the compiler. Yeah, so it's going through this init function here. Well, I guess I saw this before as well, actually. Now that I remember. Or no, maybe it was a different function. Yeah, maybe it was a different one. But I remember seeing this somewhere. So I guess this is... Oh yeah, maybe because I went through this path and then I came back and went the other way. So this just gets all the things and then create cache at environment line 83. The context class data is used for templates C class Jinja context framework. So it initializes with all these arguments for the rules, I guess, of the template. And these extra options here. Important notice. The constructor accepts quite a few arguments that should be passed by keyword rather than position. However, it's important to not change the order of arguments because it's used at least internally in those cases. Spontaneous environments, I18 and extension and template, unit tests. If parameter changes are required, only add parameters at the end and don't change the arguments or the defaults of the arguments existing already. Lexer parser information. So now is making all these attributes here to parse, to tokenize the stuff. And then runtime information, defaults, self filters, defaults, copy, tasks, global. So set the loader provided. Also now it goes through this create cache stuff. And I think I'm not really sure, but maybe it's not passing the size here, but I don't know why size is the only variable name there. Must be because it's being passed. Just trying to see if I can find this here somewhere. I'm gonna assume that's the case. It's just passing size to this. Or no, that's not the case. Size is probably what the create cache function has. Yeah, as arguments. That makes more sense. Return the cache class for the given size. If size equals 0, return none. If size less than 0, return dictionary. So that's the stuff that I was talking about between 0 and -1 on how to do the cache. and then it's gonna return the creation of that LRU cache thing. Now load extension environment line 101. Let me see. Yeah, so this is not. I also need to see what is this DQ because I remember seeing the Turing stuff and I didn't know exactly what it means. A least like sequence optimized for data accesses near its endpoints. So it's pretty much a list that is optimized for endpoints. So here is going to line 101 after it does that stuff there. Maybe I'm on the wrong file. Yeah. After it goes through here, it goes through load extensions. Environment extensions, result extension. Load the extensions from the list and bind it to the environment. Turns a dict with instantiated environments. Okay, next. Now it goes through the sanity check. So just creating the environment here. First it creates the cache, then this extension stuff. Then it goes for this sanity check thing. Perform a sanity check on the environment. Assert is subclass. Environment undefined, undefined. Undefined must be a subclass of undefined because filters depend on it. Assert environment, then it uses the rules for the stuff. For the strings and variables and comments. Block variable and comment start strings must be different. Oh, so now this is to see if the environment was created properly, I think. Yeah. Then it goes through this one, which is the final node of this small loop here. Which is where I stopped before on the set item stuff. In the utils for 42. After it does the get item. Utils for 42 here. But now I think I'm gonna go through this path first before I go this one. It's gonna be interesting to see when I do the other graphs. What I'm gonna do is actually, I'm gonna figure out a way to translate the cell vars and free vars. But first, what I'm gonna do is with the call names. The same graph with the call names on a new line. Then to see if there's any difference. Maybe after this finish, see this one also. But then after I do that, then I'm gonna try to translate the free vars and the cell vars into from the hex address into the name of the variable, see if that's possible. And then if that's possible, it's gonna be interesting to see the difference, if there are any difference or any extra information. Because now I feel like I'm starting to understand a lot more of how the Jinja stuff actually works. It's pretty much just string manipulation stuff. And I think, at least so far, the way that I'm understanding is that initially PyVis doesn't create the template. It just creates the initial template with nothing on it and no nodes or anything like that. And the standard template, when you have a file object that is passed as the argument for the environment, it just creates a blank HTML with like a blueprint for the initial setup. And then later on, after it does all this stuff, then it's gonna activate. Because I remember seeing this network X here. There's somewhere, I think, that has a function that it passes the arguments. So I think it might be this one. I'm not really sure. No, this just checks if it's on the save graph or save somewhere here that HTML here. Yeah, so this is on the same function actually. So first is creating the template with the blank stuff. That's what I imagine is happening now. With the file object, then it asserts if it's a network, check if physics is enabled, and then it passes this render method to this template. And this is probably the method that is gonna incorporate all the nodes and functionality into the template. But the thing is, when I try to put different options here and a different function on the options and make it load here, it didn't work. So that's the point I have to watch out for on this when I'm walking through here. So line 383 on the utils. And this is after that stuff. Code object get. Yeah, I think this is after. This is after the get item. So it's before the set item stuff. Which is activated here. Yeah, so realistically, this probably doesn't represent really well what's going on. It's probably running these things here before this node here, I would imagine. And then it goes through here. It's just the way that I did the nodes, slightly off. So 383. So this function here on the cache thing. Return an item from the cache dict or default. And then it goes to this Lexer again. I guess it's because of the self key here that it, when it returns, this function returns, it activates this Lexer maybe. 123. Turn Lexer, which is probably cached. Yeah. So that makes this return, which has all the rules. And then it goes through this code object. Yeah, now is the breakpoint. 445 with self. It's this file. So here, iterates over the extensions by priority. And now it's gonna go, I'm gonna go through where I stopped here before. To close this loop, then I'm gonna go to this line until I get to this point. Yeah, stopped on the set item stuff. Bring it back. Let's see something. Right back. Yeah, now I think the stuff is getting slower. Or maybe it's just perception because the number is bigger, so it seems like it's getting slower, but it's actually the same speed. It's just that it seems like it's taking more time. So where was I? Utils 442. self key value. Uh, yeah, this var names is pretty much useless. Just giving me the same information that already exists here. Sets the value for an item, moves the item up so that it has the highest priority, which is where I stopped previously. Code object from string. Line 935 in environments. Self-source globals template class. Yes, I guess it's not related to this, it's just part of the execution of the previous script, previous lines. At least that's what I'm assuming here. Load a template from a string. This parses the source given and returns a class template object. And this is gonna activate this make globals 143, which is this one's, and goes through here. CLS equals template class or template class. Then it goes through this compile again. Return a dictionary for the globals, not the return self.globals. Return dict self.globals. Dict. Code object compile at this address, line 603, which is probably this one. Compile a node or template source code. The name parameter is the load name of the template after it was joined using math. Join path if necessary. Not the file name on the file system. The file name parameter is the estimated file name of the template on the file system, which is the one that it was passed before as self.path in the network in Pyvis. If the template comes from a database or memory, this can be omitted. The return value of these methods is a Python code object. If the raw parameter is true, the return value will be a string with Python code equivalent to the bytecode returned otherwise. This method is mainly used internally. The further init is used internally to aid the module code generator. This causes the generated code to be able to import without the global environment variable to be set. Okay, so next one, 573 is probably this function here. Parse. Let me see if this is degenerate on path. No, it's not. So maybe the parse activates other functions. I just want to see if it comes back to, when it comes back to this one, should degenerate thing. Mm. So apparently it doesn't. Let me go back then. Keep going here. Internal parsing function. Yeah, is this one? Oh, it's not this one. Oh yeah, it's this one. 537. Internal parsing function by parse and compile. Turn parser, self, source, and code file name. Not parse. Just so many functions. Now it's going through the compat by file, which is this one. But I just want to see. This is another file. Yeah, so I'm missing the connection there. Line 8, lambda x. Now it goes back. Oh, now it activates that parser.py there. Huh. So it goes to this compat first. It's kind of weird. Maybe it's because of this decorator. Oh. Yeah. That's probably what's going on here. Marks the function as internally used. Maybe not. I don't see why this would activate this. Oh, maybe it's because of the frame here that is being passed. I'm not sure. But I think it has to have something to do with this decorator here. Unless the connection is not correct. But I assume what this is what's happening is activating the parse, which is this function. Uh, 537 actually. This one. Hmm. And this one activates that lambda stuff. Yeah, so this is not a decorator for this one, so it's not related. But how does this activate the other file? Doesn't make sense. That should be through the arguments somehow. There's this dot parse here. Yeah, the dot parse. But then it's not in the correct order. Yeah, this is the other step before after it already went through this compat stuff here. So I'm probably missing something, but whatever. It's not that big of a deal. This is a central parsing class Jinja uses. It's passed through extensions and can be used to parse expressions or statements. So now is making the init here of this class because of the other one. Let's see what's being passed. Source name, file name, dot encode file name. Encode file name. Ah, so here it is, compat. So I guess it runs that lambda in the beginning because it's running this function here. Or something like that. And then creates this code object tokenize 468 environment. So this one probably. Yeah, stream tokenize. Called by the parser to do the preprocessing and filtering for all the extensions. Returns a class Lexer token string. So this is gonna go to this one. One 157. So it's calling this function. Reprocesses the source with all extensions. This is automatically called for all parsing and compiling methods, but not for math flags because there you usually only want the actual source tokenized. This goes through this. So now it's closing the loop again. In the ether extensions. So it's this one. It's interesting that it didn't show this as well. Maybe it's because it was already done before. Or maybe it's just the order that is incorrect there. Calls tokenizer plus tokenizer and wraps it in a token string. And this is very complicated. Now it's going through this one. And now I have to decide whether or not. Yeah, I don't think I went through this path. But this is gonna go directly to the main file here. New Lexer 365. I'm lost on where I was before. Yeah, so I was here and there. So this is probably gonna be, yeah, it is actually the initialization of the Lexer. After it prepares all this stuff, and the Lexer is probably the tokenization. So set item 142. Oh, it's another file. I wonder how long it took for people to build this library. So it goes from here to line Lexer line 613. Acquire is not gonna get me there. Just open manually. Oh, I was already on the spot here. Calls tokenizer plus tokenize and wraps it in a token string. So now goes from that to init in 327. Just probably this, or maybe yeah, it should be this one because it's creating this object here. A token string is an iterable that yields class token. The parser, however, does not iterate over it but calls math next to go one token ahead. The current active token is stored as attribute current. So it creates iter dq name, file name, closed, current. And then from this, it goes through the main one again. Which closes the loop. So I guess I didn't go this route. Yeah, I think I went until this point. Yeah, I went to this point and then I stopped on this one. So I think I'm gonna see the connection here before. This part is tough because it's a little bit confusing. So in the ether environment, just this one, it goes to parse, no, 25. And parser.py, which was the stuff that I was seeing before. And then from here, it goes, oh, so this is also connected to this main one here. To 887 parser.py. It's probably this template. Parse the whole template into a template node. It's probably this thing here, subparse. Gets activated. Body buffer and data. Yeah, okay, so now it goes through here. And 339 lexer.py. 39 here. So it's still on the same object as before. I created. Now it's just accessing the method of that object in the subparse method. Maybe it's this flush data stuff. No, it's probably not. Yeah, one of these functions here is probably activating this thing here. Yeah, I stopped here, I guess. Parse post fixed. Parser pi 694. I don't want to go into every single one of them because then I'm just gonna get lost, and I think I wanna try to get go faster through this portion, especially because I'm getting tired already. Maybe I'll stop here, go for a run, and come back later. I want to be careful to not go super fast so I don't miss the transition and the connection there between Jinja and Network X, but also not go so slow that I'm paying too much attention into the details and losing track of what I actually want to do, which is to add the functionality there to the page. So activates this function here, and this also is connected to the Lexer there object. Calls are valid before after postfix expression get attribute and get item as well as filters and tasks. Let me see what this is. Nodes.py. So I guess this happens after you created everything for the template. I need line 150. So is this class here with meta class. Wow. I'm gonna read this stuff later. Base class for all Jinja nodes. There are a number of nodes available of different types. There are four major types: class, statements, expression helper nodes, the outermost wrapper node. All nodes have fields and attributes. Fields may be other nodes, lists, or arbitrary values. Fields are passed to the constructor as regular positional arguments. Attributes are as keyword arguments. Each node has two attributes: line number and environment. The environment attribute set at the end of the parsing process for all nodes automatically. And this also activates the parser filter expression, a line 707 in this thing. So this token type equals self string current type, if token type equals pipe. The only thing that I'm not understanding here is that so far I think I'm getting that when you create the template is gonna create the HTML stuff, the basic skeleton, let's say. But I don't understand exactly. Maybe it's because I don't understand what the file object of the network X of Python actually really is. Yeah, that's probably what I'm missing here. Because I guess the stuff that is parsing is the object from Python itself, which is a file object. And this is why it's going through all this tokenizing stuff. It's just transforming the file object on Python into either JavaScript or HTML. I'm not really sure the format. Just transforming this object here. But I don't understand really well what the object looks like in Python, the built-in thing. And here you're just gonna have pass attribute because of PyCharm. Yeah, but maybe it's not that important to know. It's probably more important to understand the render stuff later for what I wanna do. Open file and return a string. Raise OS error upon failure. No special case of open. File is either a text or byte string given the name and the path. Damn, maybe I just do this to read this. Status path. If the file isn't in the current working directory, or the file should be open, or an integer file descriptor. If a file descriptor is given, it is closed. Okay. Mode is an optional string that specifies the mode in which the file is opened. It defaults to read, which means open for reading text. Other common values are write, an X for creating and writing to a new file, an A for appending. In text mode, if encoding is not specified, the encoding used is platform dependent. Local.get prefer encoding false is called to get the current local encoding. Yeah. Blah blah blah. The default mode is RT open for reading text for binary random access. Python distinguishes between files open in binary and text modes, even when the underlying operating system doesn't. Files opened in binary mode, when in B to the mode argument, return contents as bytes object without any decoding. In text mode, the default or when yeah, but this is not gonna, that's the thing, it's not gonna have any information on what the object actually looks like, because it's probably written in a mixture of C and Python. But I guess this is what's happening here. Is getting that basic object file from Python and transforming that into HTML or JavaScript, or both, through all these functions here and classes. So yeah, here's push data from the other functions. Oh, so what else? Yeah, I think I have to go through this thing first before I continue there. I think here I'm just gonna look at the main ones, and then I'm gonna continue to the other stuff. I think I'm gonna go a little bit faster and slow down once I see the transition between Jinja and Network X again. So because I think I already got the gist of what's happening, so probably don't need to worry about the details so much. So in this lecture, object next, line 377. So after it creates this string, it's probably creating. Oh, it's on the creation of this token string. It calls this initialization. So this comes from the new in the lecture 365, which is the class token. Tuple.new, which is the one that I already saw from before. So this creates the token, and then based on the other functions, it creates the token string class. And this is what this node is on the 377, which is the new for the token string object, which gets called before the init. Or maybe not, mistaken, it's just next, it's not new. So it creates the init first, and then runs this method. Go one token ahead and return the old one. Use the built-in funcnext instead of calling this directly. One token ahead and return the old one. And this is connected to this stuff here. 662. This method tokenizes the text and returns the tokens in a generator. Use this method if you just want to tokenize a template. So source text type, which I don't know what it does. We only match blocks and variables if braces, parentheses are balanced. Continue parsing if the lower rule, which is the operator rule. Do this only if the tags look like operators. That's 718. Yeah, so this is just going through the process there, which is this whole function here of the the tokenizer. To normalize it to Unicode. So this goes here, goes back to this new stuff, the class. Luxer 618. This function here. This is called with the stream as returned by tokenize and wraps every token in a class token and converts the value. And this is gonna activate this next in the other thing. I think this one I didn't see. So 275. So it's this one here. That's a token against a token expression. This can either be a token type or a token type, token value. This can only test against the string values and types. Here we do a regular string equality check as test, any is usually best an interval of not interned strings. So this is just testing the tokens, I guess. Just gonna activate all of this other stuff. Maybe I should work backwards to the point that I want and go back. I think I'm gonna stop shortly to take a break. Just because I'm already getting tired. This is just parser stuff. Parser. Parser. Parser here as well. Yeah, so I guess that's the structure of the thing. I think one thing that just hit me when I'm doing this, when I'm visualizing these graphs, is that the ones that have the most connections are probably the classes, and then the others are the methods of the class. And usually that's the way that it gets. It is a structure where you have different classes. You're gonna have the sequence of classes, which are the big nodes. And around that sequence, you're just gonna have a bunch of methods of the same class that achieves a certain goal. So it should probably next time start with the big ones, and then see what are the main classes, and then try to understand the logic from that. And I think this is a pattern that I'm seeing from all these visualizations that I'm doing, is that I think the way that people think about when they are building this stuff, they think about the classes first, the big nodes first, and then they derive whatever functionality from that, which makes sense. So now I think I'm gonna skip all these other ones and I'm gonna continue into the next one. And the only question is how people think about these connections between the big nodes on the initializations and things like that. And I think that depends cases by cases, but there must be a common trend between them as well. Because then that's when it gets a little bit hard to understand. Is when you have the connections between classes with meta classes and both with different classes calling functions from each other, or one function activating a class on another one. So how does that work? Is the thing. Yeah, now it gets to the very complicated part. So let me. So the final here is the node. After it does all this stuff, the tokenization stuff, creates the node. Then goes to nodes.py. And I want to understand this bridge here before I look at the main classes in the big thing there. Set environment. Set the environment for all nodes. So it uses this DQ data structure while to do, and while that is true, node to do dot pop left. So it's just appending a bunch of nodes, making the environment of this node equals the environment. Then is extending the node to through ether child nodes. Iterates over all direct child nodes of the node. This iterates over all fields and use the values of their AR nodes. If the value of a field is a list of all the nodes in that list, I return. Oh, if the value of a field is a list, all the nodes in that list I return. This method iterates over all fields that are defined and use key value tuples. Per default, all fields are returned, but it's possible to limit that to some fields by providing the only parameter or to exclude some using the exclude parameter. Both should be set for tuples of field names. Okay, so let me go to the next one. Yeah, so here it starts getting into the big thing already. No, it looks like it has a connection, but it doesn't here. So now this is gonna go to this. Their child nodes. The stuff that I already looked at. Now I think I'm gonna look at the big ones because it's too many here. Get visitor. So I think that's all node methods. I don't understand what a node is actually. Didn't think I understand it properly. Because in my mind, the node was after it parsed all this stuff, it would get everything into one node. But maybe there are several nodes that get created for the tokens. Maybe it's one node for every different rule or something like that. visitor pi. Line 20. API for traversing the Asd nodes implemented by the compiler and meta introspection. Aux abstract syntax tree and call visitor functions for every node found. The visitor functions may return values which will be forwarded by the visit method. Maybe I can just search what are nodes in the... Maybe someone has made a video about that. That will be easier to understand. I forgot to change the headphones. I forgot to change the headphones. I forgot to... the issue is that the videos are gonna be just about the basic stuff, I assume. The issue is that the videos are gonna be just about the basic stuff. Hopefully they don't stay like this for the whole thing. Even the echo. So maybe if I search on directly here. I don't think that it was giving the echo because I wasn't seeing that. Let me test. Hello? Hello? Or maybe he's muted, so... Yeah, let me test again. Or maybe he's muted, so... Yeah, so yeah, he wasn't giving the echo. That's fine. Yeah, I guess I will read this stuff later. So this is the node, nodes, either child nodes. There's so much complexity to build in this simple stuff. ID tracking, why? This is a different file. This is this one. This is probably making each node unique or something like that. I just want to see if in the middle of all this stuff there are some network X things. So visitor, nodes, Jinja nodes, visitor, 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 nodes. So apparently just nodes and visitors in this portion here. Nodes as well. Nodes, nodes. I still don't understand, however, the connection between the parsing stuff and the nodes. Maybe I should go back to the previous one and go more carefully there in the transition when it actually creates the node. It's hard to understand because I don't really understand the Python object thing. Maybe what I should try to do as well at some point is create a fake class or pass anything as an argument there to the template and see what happens. Or maybe I can just put a string or something like that and see what happens. So this is visitor still. Visitor compiler. So this one is slightly different. But it's still Jinja2 stuff. Nodes. Nodes. Compiler. Nodes. Compiler. So nodes, compiler, and visitor are the ones that are being activated here in this whole thing. Yeah, I think that's it. And then here are just small nodes. So all this stuff is just still from Jinja. So far from what I get from this is first creates everything in PyVis, then creates the normal template here. The normal template parses the object file from Python into the tokens through the Lexer stuff. Also uses the LRU cache to optimize for access, I guess. And then after this runs, it creates a bunch of nodes. And then these nodes are goes through a bunch of functions here that I don't understand, but yeah. And then from these nodes, it compiles as well. And I think it organizes the nodes and compiles them. And that's what all this stuff is doing. And optimizer, then I assume that the last portion is going to be the network X again, once it's rendering the template. Because now it has all the information that is needed for the skeleton of the thing. After it runs all the nodes and the stuff there. Yeah, you can see now that it slows down. So this might take very long amount of time to complete, but I think I'm gonna let it run until it finishes. I think there is around close to 900,000 steps here. And I'm gonna let this finish because I wanna look at the sequence without losing because it was a little bit confusing there. I wanna see if it's gonna be easier to figure out. And then I'm probably gonna try to do the other graphs as well. After I'm gonna stop now, take a break, go for a run or something like that. Then I'm gonna come back. When I come back, I'm gonna spend more time trying to figure out the connection here, but I don't think I'm gonna dive in the specifics a lot because I think it's gonna be better to figure out the graphs first. The other types of graphs with the cell vars, free vars, the code names for other names of the globe scope. And then once I have that, once I found the best one, then I'm gonna do the sequence for the best one, which is gonna take a long amount of time. And by that time, I expect that this is gonna be done already, so I'm gonna check this graph as well. And then once I have that at the end, then I'm gonna probably try to, because then I'm gonna already have a lot more exposure or from the Jinja2. I feel like I already got the gist of the big vision, let's say, of how it works. Then once I get enough exposure to the point that I start to understand the connections between everything, then I think I'm gonna modify the source code in various different points where I think that I'm not quite getting what's happening. Then I'm gonna modify, break the thing on purpose, and then try to figure out what's happening until I finally find the breaking point that changes the information here on this page and the functionality of the nodes. So that's the plan. But now I just want to get to the network X part until before I stop and take a break. So visitor, that's probably here on this last node here. Yeah, so it is here. So here's still Jinja2, optimizer, visitor, Jinja nodes, also still Jinja nodes. So maybe the network X is just the Jinja2 stuff as well, which is bad news because that means it's gonna be harder to figure out where's the breaking point, because I'm gonna have to dive into the stuff there. But it has to come back at some point for the activation of the PyV's stuff. At least I would think so. Maybe not. So it seems like all of this is just still Jinja. Yeah, now finally after all this environment stuff, then it goes back to the PyV's line 377. Get network data, which is this portion here. No. 377. Oh yeah, it's activating the function, but it's after that other line. So only on this node here, it goes back. So all of this stuff is just the Jinja part of making everything. All of this stuff here only at the end, it goes back. And this is already options. And this is the last node. Then dent level. And this is interesting because I don't see any of this information here of the variable names in here. So I guess this is an extra thing that I got here from the var names. Extract relevant information about this network in order to inject into a Jinja2 template. Yes, it looks like the variables at this point are all current ident level, which is probably coming from Jinja2, and marker ID. And then this goes through the 229 option spy, which is this. And to JSON. It's running this function for the options. So converting the options into a JSON format. Then options. It's running this lambda function here in the same thing. It's marker ID, new line ident, item separator, first items, key, value chunk. So this is interesting. Because before I did not have access to this thing. To the name of this stuff that exists here. It's still the lambda function there. And now it goes to the Jinja environment again for the render stuff. Environment, finally closing the loop. Because now it's gonna render the template I created before. $1,076. This method accepts the same arguments as a dict constructor, a dict subclass, or some keyword arguments. If no arguments are given, the context will be empty. These two calls do the same. This will return the render template as Unicode string. So that's the stuff that is the problem, because there's no way around it. I'm gonna have to understand how the nodes are connected there. Because if I just put a simple function here, simple add another stuff here, it's not necessarily gonna do what I think it's gonna do on this part here. Which is the portion I'm having trouble understanding. So this returns, maybe I should write it down actually. What? Yeah, begin with the end in mind. So that's what I should have done in the beginning, I guess. You just go to the end and then write down all the things that are happening here at this point. So as I'm going through the process there, I can see when they show up in the node creation. New contexts are definitely remembered at some point. Some of the functions created this thing, created a context. Then from this, it goes to runtime. The new context, probably this stuff. Then runtime again. Node stuff by 966. Then compat, runtime, runtime, runtime filters, utils, and then filters. Yeah, alright. So I think I'm gonna take a break now, and I'm gonna probably come back later from this last point here. I'm gonna go back until it renders. Yeah, this is the last one. Oh. Yeah, this is the moment here. Where is it? Oh, it's way before there. Actually. Yeah, I forgot because I'll figure out, I'll find it later. So I'm gonna take a break now, probably come back later today.